Good afternoon, everyone. Thank you so much for joining us today for our This is What a Scientist Looks Like panel. My name is Jessica Hay. I use she, her pronouns, and I am with the National Girls Collaborative Project, a nonprofit working to ensure gender equity in STEM and really encourage girls to pursue STEM. I'll be facilitating this panel. Not really. There's mostly superstars. I'm just saying hello. And I'm going to be facilitating it with the help of some incredible young women from our Girls Advisory Board. We have Bella, who is a junior and is super passionate about service work and relief efforts and hopes to do some humanitarian work in the future. Bella works on social activism projects on a variety of different fronts, including starting a nonprofit with her peers to educate youth about climate change. So that's pretty amazing. And then Hajira is also a junior in high school who's passionate about robotics, engineering, and just STEM in general. Her ambitions are channeled into a drive to inspire minority girls to join careers in STEM. She aspires to become either an electrical or robotics engineer. And then Megan is a rising sophomore who has always demonstrated a strong passion for STEM, specifically biology and biomedical engineering, but also computer science, coding, really all the things. Her goal is to normalize girls in STEM and spark the interest of young women to pursue STEM-related occupations through her community. So I'm so honored that these young women could join us because they are definitely inspirational for me, and I'm sure will be for you by the time we're done. I'm also really, really excited to announce our panelists. So first we have Katie, who is a PhD student and artist at Stanford University. Also, Katie's video is so exciting because there's a dancing robot, which just makes me really happy. And every time I see it, it brings the biggest smile to my face. So I'm gonna play a little intro video for Katie, and then we'll announce the rest of our panelists. Maybe we will. Technology.
My name is Katie Kwan, and I'm a robot choreographer. I started dancing when I was 3, and I started using the internet when I was 9 years old. And I started to think that technology was going to be a part of my life in ways that I could have never imagined. But it was really in 2014 when I saw my dad get sick and be surrounded by machines that I thought there could be a much better alternative to robotic technologies, and there could be ways of making people who are less familiar with robots feel safe around them, and performing artists are really great at reframing the story and telling you something different. I think I was 25 or 24 years old at the time when I first started working with robots, which is a little bit later than most people would expect. But since then, it's just been my full-time job to work with dance and robotics. So my first class that I took at Stanford was a coding course. I started out in that class so challenged, so frustrated. I felt like I could never learn anything. And I went to every single lecture, I was doing every single homework, going to tutoring, asking for help, and I was still feeling so challenged. And it wasn't until the end of the year when I realized that all of the tools that I had been learning, I could basically program robots with that coding language, that I was like, oh, there's an application. I can take this outside of the class and I can use it in my research. And when that happened, it really helped me alleviate some of my frustration that I had about programming and learning how to code in a new language. When I graduated, I started to work with robots mostly in my artistic work. So I was creating dances for robots, I was using them inside of performances, and I thought, I'm really studying how the audience feels about robots. We tend to think of performance as entertainment, or we tend to think of performance as, only for the arts, but we can learn so much from performance and shows as well. And so for me, it felt like a major achievement to kind of formalize or put a frame and a wrapper around a show and say that this isn't just art, it's also research, and the two can benefit one another. I'm inspired by robots that can do things in our daily lives, but also robots that can help to solve some grand challenges, from climate change to access to healthy and clean food to healthcare and aging populations. And I think we have these kind of macro, not only nationwide, but global issues, that we can not only use robots, but we can use robots creatively to help solve some of those problems. I work with other students, I work with postdocs, I work with undergrads, faculty, and then people in the creative community. Folks who write to me, you know, a lot of the times people will send me, oh, I've been thinking about this, or watching you made me ask this question. And so I think that my work is actually quite collaborative, and I feel very inspired that I can think about them, and if some of my work has a small impact in a positive way for people beyond myself, then it will feel like I've had a huge success.
I told you all, a dancing robot. It's very exciting for me. All right, next up, we have Sam, who is a biologist and science educator with the National Park Service at Cabrillo National Monument. And this picture of the snake makes me really happy. If you really enjoy Sam's video and you enjoy this video of this, or this picture of this snake, you should definitely check out the If Then Collection webinar or workshop later this week, and you can learn more about Sam's work.
Sam wins, 1 mark. Hi, my name's Sam Wins, and I'm a conservation biologist with the National Park Service. I'm a biologist, which means that I study life. And at my particular park, Cabrillo National Monument, it's my job to preserve and protect everything that lives there. So I go out into the field and study every living thing at the park, every plant and every animal. I think what's interesting is, despite the odds, it's the women in my family who work in STEM, even though statistically there are more men in STEM than women. So my mom was a registered nurse and an entrepreneur. She owned her own business. My aunt was a biologist, and my sister is a veterinary surgeon. I'm very fortunate that I had these strong female role models in my life to inspire and encourage me. I like to say that we're standing on the shoulders of giants. I mean, I can only be a scientist as a female today because of all of these pioneering women, from Marie Curie to Mae Jemison, right? Or Jane Goodall is one of my idols. I'm very fortunate to have them. When I was little, I grew up outside of Yellowstone National Park. It was basically like the ultimate backyard. And being out in that incredible nature and seeing like an osprey diving into the water and picking up a fish, and a grizzly bear and her cubs, right, really inspired me to want to preserve and protect that beautiful diversity of life. I thought I was going to be a marine biologist, and then I realized I get horribly seasick. So I thought maybe that wasn't the best path for me. And eventually I came back to conservation biology as a whole. One of my favorite things about my job is not only being out in that beautiful nature, but getting to inspire others to care about the beautiful diversity of life on this planet. As a conservation biologist, it's my tenet to preserve and protect, right? And getting to light a spark in others about like how beautiful these things are and why we should protect it is just perfect for me. The best piece of advice I've ever received is to be yourself. I think things come to you in life if you're true to yourself, if you're honest with yourself, and you get to follow your passion. If you have a passion, then you should pursue it.
Oh, Sam, I love that video every time. I love hearing about the women in history that have inspired you. I mean, it makes me want to research them more, and I'm sure all of you watching want to do that too. Okay, last but not least, we have Claire here joining us, and Claire is an assistant teaching professor in everyone's backyard that's down there, University of California, San Diego. So that's very exciting. Both Sam and Claire are in San Diego. And hopefully the video plays.
My name is Claire Metters, and I'm a postdoctoral associate at Cornell University in the Ecology and Evolutionary Biology department. I do biology education research. I study how students experience their college STEM courses, but I also study how those courses are taught. And then I share data back with faculty. We meet as a community throughout the whole semester, and I share data with them, and they bounce ideas off of each other of different innovative types of teaching they can do that can address the things that come up in their student surveys. And so that's been really fun, just getting to see this community of faculty that are all super engaged in teaching and wanting to improve teaching for students, and then actually making changes to make their classes even better. I'm inspired by my students, and teaching during graduate school gave me that drive to learn more about how to improve as a teacher, and my training as a scientist made me want to use evidence-based methods to measure my teaching. And then I wanted to actually participate in the research of that. I've always loved biology. I was working in a lab that really empowered me to feel like I could actually be a scientist and look through the microscope and make discoveries. I think that like all problem solving requires some form of creativity in general. So every time I have a research question, I have to think about, all right, what are the best tools to use to address this question? And so that inherently requires creativity. My mom didn't go to college. She immigrated from the Philippines, and so she actually did not have any of the career opportunities that I have had. And so I think that definitely plays into what I do now and my motivation to share open doors that I've had opened to me. I've seen what the power of a STEM education can do, and I really want to share that with other people. If you help a woman build her support network, then that network will eventually reach across the world.
Oh, thank you so much. You all are so amazing, and I love hearing about the work you do. It brings me chills every time I get to watch some of these videos. So thank you for joining us today. And we have some questions for our panelists. But if you do have a question, if you're watching this and you do have a question, you can always pop it in the chat box, or you can use that Q&A function as well. And we'll monitor that. And if we have some time at the end, we'll add those questions in. I'm excited to jump into our conversation. I'm going to stop sharing my screen so that we can really see everyone a little bit better and see our panelists. So I'm going to just hand it right over to Bella, who's going to kick us off with our first question.
Hi, everyone. So our first question for you guys is, because it's Women's History Month, can you tell us about a woman who has inspired you throughout your career?
And this is just free form, so jump right in, Sam, Katie, and Claire.
All right, I always feel like I talk first, so I was waiting for Claire and Katie, but but you still hadn't unmuted, so here I am talking first again. Well, you heard a little bit about the women who inspire me, but one thing I didn't mention that I think is really important to do a shout out to is all the unsung women out there who are just quietly doing the work every day. And we all have some of these women in our lives, whether it's in STEM or, our moms, or just nurturing us, right, and helping uplift and support us on our journey throughout life. So shout out to all of those ladies out there. That's what I have to say. Passing it on.
Yeah, thank you for highlighting that, Sam. That actually, when I saw this question, what I thought of, or I definitely have a ton of STEM heroes, and I know you all have been introduced to the If Then collection, which all those women inspire me. I'm also going to drop 2 links in the chat of other resources where you can find real life scientists. Scientist Spotlights and Project Biodiversify are fantastic resources for highlighting diverse people in STEM. But yeah, like Sam was saying, whenever people ask me who inspires me, I always think of my mentors. And these are women I've been lucky to have been mentored by. When I was an undergraduate working in a plant lab for the first time, I worked with a female graduate student. And then all of my PIs, or the principal investigators on projects throughout graduate school and my postdoc, were all women. And they just they're not like famous. I mean, they're famous within our fields, but they're not like celebrities, but they inspire me just because of their ability to do amazing science, but also just always make time for their students, for their labs, I feel like it's something where women often take on these roles of being the support people in networks. And I think that's something that definitely, like, as a society, we need to work on, but having people in those spaces is so critical just for the next generation of scientists. And I know I benefited from that when I was a graduate student, definitely dealing with imposter syndrome and which I'm happy to chat about later on as well. But like having these women in mentor roles for myself who are further along in their careers really showed me that like I too could do that and be a professor someday. And yeah, they inspired me and paved the way.
Great question. I have a number, like Claire and Sam, of mentors, women in my field and beyond, who have really inspired me. But because it is Women's History Month, my grandmother never got anything past a 6th grade education. Her name was Irma Rosa. She was born in Havana, Cuba, and she used to work in a cigar factory. And when my family came to the United States, so I'm first generation, my dad immigrated here, and my grandmother came, I think she was so unbelievably thrilled that in one generation, we could be college educated young women who really had the ability to pursue our dreams and be fully independent. And so I have so many mentors, just like Claire said, my PI principal investigator, Allison Okamura. She's someone I really admire in the robotics field. There are so many titans where I'm at school at Stanford University, great women role models. But for me, when I think about this month, I really think about my ancestors and the women who have worked so hard for me to even exist on this earth, and for me to pursue career possibilities and dreams that they might not have ever imagined. So that's what that question says for me.
The next question is, why is it important for girls to see women in STEAM careers?
This is something I think about a lot in my own experience. So I had 2 teachers growing up, Jackie Miller and Miss Malarkey, who was my 7th grade science teacher, where I had these interests in science and math, but it wasn't until I got to see them teaching it, shepherding that knowledge to me, that it seemed like I could see myself in a future like that. There are so many representations of scientists, whether it's in cartoons, books, movies, etc., and they don't always look like you. And so when you have a role model, not only in these story-based representations, but also in your life, I think it changes the story that you tell yourself about who you are. And at If Then, we really love this saying that if she can see it, she can be it. The transformational power of a role model is what incites that spark of possibility. And then there's a lot of work and mobilization and time spent that takes to actually get you there. But if you never have the spark of possibility in the first place, it winds up being a dead end. So I think for me, the big answer to your question, Megan, is you need that spark of possibility. You need to see it, and then all of the nice long paths that we have to walk down to realize those dreams will happen, but you need that light, that match to go off.
I completely agree with Katie. I think it's so important for motivation and just to visualize yourself in a career path. Having someone that looks like you or that you connect with can make something seem just a lot more attainable. But it's also so helpful just for like all the women in that If Then collection and beyond. Like there's so many different career paths in STEM. And when I was your age, I mean, I went to college pre-med which is a great career. But at the time, I thought that's what you did if you liked biology. I just didn't know that there were so many other career paths. And I learned later on once I was exposed to other mentors. But I think like the earlier that we can provide young women with mentors in STEM and also access to knowledge about all of these amazing careers in STEM, the more likely people and young women like yourself will actively pursue those and just really be this next generation of scientists who help us tackle a lot of the world's problems.
Yes, yes, and more yes to all of what was just said, but to build a little bit on what Katie and Claire was saying, you know, not only do we see this personally within our lives, but there's actually, guess what, scientific research to support this idea that people cannot follow a path if they don't see themselves in that position. When girls were asked why they decided not to pursue STEM, or as you know, they got older, teenagers were asked this, young college students were asked this, the number one reason that they cited was because they saw no one in that position that looked like them, right? And so finding those role models, being those role models, right? And I was fortunate enough that I not only you know, had these titans in STEM, like Marie Curie, right? But I had personal role models in my life, you know, my mom, my sister, and my aunt, that I grew up believing, never thinking that it couldn't be any different for me, right? Knowing that I could do this. But there's a lot of people out there, especially girls, who don't have this opportunity. And so this is why it's important to provide that opportunity at all costs, like at all times that we can with the If Then collection.
All right, my next question is, what advice would you give to your 10-year-old self if you were able to travel back in time?
I can start. So, oh my gosh, it's hard to pick one thing that I would tell my 10-year-old self, but I think I would definitely tell my 10-year-old self not to worry about picking something, because I think you can pursue multiple interests and hobbies and passions and merge them all together in one career path. I think like STEAM, this is science, technology, engineering, art, math, like there's so much crossover between all of those disciplines and so many jobs that just haven't even been created yet. And so by pursuing all the things that you're interested in, you're inherently training yourself for a career path in the future that's for you. I also, though, I'm going to sneak in a second piece of advice, just because I think I spent so much time when I was younger just being afraid that if I wasn't good at something right away, I wasn't going to be good at it. And I think that's something that I didn't learn about this concept of growth mindset until much later on, where if you put in practice and time, you will improve in whatever you're working on. And I wish that my 10-year-old self had kind of connected that a little bit earlier.
Yeah, I think I'll go next, because I actually want to build on that too, because this is what I was going to touch on, Claire. I think I would tell my 10-year-old self that it's okay to be afraid. I almost didn't pursue my biggest passion, which is biology and conservation, right? Protecting nature, because I was really afraid that I would fail at it. And guess what? You're going to be afraid a lot in your life. I'm afraid of public speaking, and here I am doing it right now, right? It's really what you do with that fear that matters, right? Don't let your fear prevent you from pursuing your passion in life, because that's something you will always regret, right? Push through the fear. And it's okay to fail, right? In fact, you're going to fail a lot in life and in science, and that's just part of the process, right? When you look at it as a growth mindset, as Claire said, then you can actually end up pursuing and achieving the things that matter most to you.
I need to hear that advice right now. It's like, I think part of being in grad school is just to fail all the time, because by definition, you're making new knowledge. So no one's likely done ever before what you're trying to do. And it's really hard to get advice and can be scary and frustrating. So thank you both. I needed to hear that. I think to my 10-year-old self, so very real. I got teased a lot when I was 10 years old. I was made fun of a lot for being a smart girl and being very outspoken about it, raising my hand every single day, every single time in class. And I was so driven to want to learn and share that it actually got me teased a little bit. And so I think what I would have said to my 10-year-old self, which is what my parents said to me at the time, and I'm very grateful that they did, you've got to be who you are. You've got to be yourself. And if you're thrilled about school and you want to be there and everything is exciting, then that's all that matters, because people, no matter what age you are, people are going to judge. They might, make assumptions about you, and you can't listen to those outside voices. You've really got to follow that inner vector. Use some of my physics and comp sci knowledge. You've got to follow that inner vector and follow that inner voice that's telling you you can do this. And despite the naysayers, it's okay. And I love what Sam said about fear. Fear is just a very natural emotion when you're doing things that are challenging. I experience fear every day. I get asked to do things all the time that are really hard. And so it's completely normal and natural that you would be reacting to a challenge with fear, and that's okay. And so I think becoming familiar, accepting of the fear, moving forward in the challenges anyway, and then following that inner voice that tells you you don't really have to care what other people think is the two things that I would tell my 10-year-old self and my current age self. So yeah, great question.
Don't worry, Katie, we'll help remind you every now and again. If you
I know, this is
what's remind me too, right?
Yeah, so what's so great about the If Then community too. I think it's a lot of women who are encouraging of one another, and yeah, maybe that would be a 10-year-old bit of advice too, is support, encouragement, be there for other folks, and they'll be there for you.
Find your tribe, find your support network, for sure.
Okay, well, I'm like on the verge of tears. That's amazing advice. I definitely needed that right now. But my question is, how does your work impact the world?
I can start. So I think one thing that is fantastic about STEAM careers is you really have the potential to make impact at scale. And when I mean scale, I mean millions, if not billions of people for the next tens, if not hundreds of years. Just think about like personal computers, right? And how we were able to transition from these giant room-sized computers to these small laptops that I can pick up and move around and hold in my pocket. And all of the human potential that was unlocked by that transition in technology. So I work with robots, and robots are undergoing a very similar transition. They used to be these 2,000, 3,000 pound giant industrial machines that were in cages and behind locked doors, and now they're coming out into the real world. And people like me and like my family and like everyone in the general public is going to have the chance and the opportunity to own a robot one day and do something with it, if you don't already. So I think for me, when I think about how my work is impacting the world, it's creating devices, algorithms, tools to control those robots that hopefully, this is the hard part, the hard work, that hopefully make them much easier to use and much more accessible to a broad group of people. And when that happens, you can see not the tens of thousands of people that are using robots now, but millions, if not billions. And I talked about this a little bit in the video, but the potential for robotics is really endless, because we've just seen the potential for computers to be quite endless, and robots are embodied. So it's not just that they have computation, but they can actually move around and reach out and touch the world. So that's what's really inspiring to me. And the quick caveat that I'll also add is, in order for that to happen, we need a huge number of people to start working on some of the grand challenges in robots, and they all need to be from very different backgrounds, because in order to build something that's for everyone, you need everyone to build it.
I can follow Katie. So I think my work is a little bit at a smaller scale. So I do research on how we teach biology, and I want to answer the panel question, but I think I can also answer a question that came up in the Q&A, which was, why do we think there's not a lot of women in STEAM? So there's quite a bit of research out there, at least at the college level, about how students enter college wanting to major in STEM and then change their minds because of experiences in these large introductory classes, or just feeling unwelcome in STEM, unwelcome in their majors, And so a lot of the research that I do is to try and help fix these issues of student experiences in intro classes so that any student who comes into college wanting to major in STEM feels supported and feels like they can do it and keeps feeling that way throughout college so that they successfully achieve the majors that they set out wanting to do. So I think my research can impact other faculty in that way and kind of help address this problem of disproportionate lack of retention of women in these majors. But then also as a teacher, I love that I get to actually teach biologists. And I think that's one of the coolest things for me. We're wrapping up winter quarter at UCSD, and this quarter we actually had students do a take-home experiment where they got to do CRISPR, which is this gene editing experiment at home. So like from their living room, students were creating these knockouts of genes in yeast and just seeing their reactions to this really cool experiment and seeing them identify as scientists is something that like really makes me excited, because these could be the next future like titans in research themselves. And so it's cool that I get to influence both the teachers, but also the students in the classroom.
Okay, so we're gonna do a little exercise together. I want you all to think, imagine, picture your favorite animal or your favorite plant. Okay, if you have that in your mind. The work that I do directly translates to saving that species from extinction. So as a conservation biologist, right, not only do I study life, but I work on finding methods to preserve and protect that life, to keep those various different species from going extinct on our planet. Which of course, I do it in a smaller scale at my particular national park, but the research that I do gets, put into that beautiful large database, worldwide database where anyone can access that research. But that being said, I actually think I make a bigger impact with science communication and science education, as Claire was just saying. I like to call it the ripple effect. So think about when you throw a pebble into a pool of water, right? A pond or a lake or something, and the ripples that come out from it, right? So being able to inspire one person to care about our planet, to become an environmental steward, right? Or inspire them to become a scientist who might grow up to study these things like climate change and biodiversity loss, right? The effect of inspiring that one person then ripples out to their community, right? And then a bigger community from there, and a bigger community from there, and a bigger community from there. So I'm really fortunate that I get to both do science and contribute to that scientific database, right? To our scientific knowledge to preserve and protect species, but then also communicate that science to inspire others to care and make changes in their life as well.
So the next question is, what or who encouraged you to pursue a STEAM career?
So I'll go first on this one. So you've heard a lot about, my various mentors and where I grew up outside of Yellowstone National Park. So being able to be out into nature and seeing nature at work was really extraordinary and really inspired me to care about it and want to study it. But when I was younger, I actually didn't realize that nature needed help until a very specific example. I was a little younger than you. I was around middle school, where something called the Exxon Valdez disaster happened. And the Exxon Valdez was an enormous oil tanker that crashed off the coast of Alaska and spilled millions of gallons of oil into the ocean. And I distinctly remember sitting in front of my television and just crying as images of all of this incredible wildlife, like sea otters and various different birds that were coated in oil and dying from this horrible disaster. And it was that kind of like aha moment, that light bulb moment for me, that I realized like, oh, not only, is nature cool, do I want to study it, but also nature needs help. Humans really like to change the planet, and not always in good ways. So I really wanted to make sure that I was lending my efforts to studying and then supporting nature, helping nature. That's what inspired me.
I can go next. So I think I mentioned before, I came to college pre-med just because that's what I knew growing up, and I was convinced I was going to be a medical doctor. And I think what convinced me to try out STEM was really just barriers being lowered for my own participation. So specifically, a professor came and gave a guest lecture in a genetics class that I was in, and mentioned at the end that he was hiring undergraduate students for summer research in his lab. And I was like, you can get paid to do summer research, what? And so I went and talked to him, and because he was so open and advertised in class and left his email and office hours information, I was able to get an undergraduate research position, and then ended up doing research for 2 years, writing a senior thesis, pursued grad school. I saw there was another question in the Q&A, how were you able to finance your education? In undergrad, I definitely received quite a bit of financial aid and scholarships, but I want to highlight that PhDs are, at least science PhDs are free. So my university covered my tuition and also gave me a stipend, which I didn't know was a thing when I was growing up. And definitely when I learned about PhD costs versus med school costs, that, not gonna lie, that definitely played into my decision making, as well as how much I loved research in the lab. But I'm definitely grateful to the professor that just was super open about inviting undergraduate students to do research. And it really was like my first time looking through a microscope at these like transgenic pollen that I had made, and seeing like I had added this green fluorescent protein to them. So these pollen were glowing under the microscope, and it just was incredible. And I think I know a lot of students have these experiences really early on through after school programs where they're doing hands-on work. And I just think those can be such transformative experiences. I didn't have mine until college, but I'm still here. So it can make a big difference.
So I talked about this a little bit in the video, but I actually majored in business and dance in college. I got an A+ in physics my freshman year, but was so put off by the experience that I decided not to study anything scientific at college. I didn't have very many friends who were majoring in science, and it was sort of hard to imagine myself, moving through 4 years of undergrad with a science degree. So after I graduated, I wound up kind of splitting my career between being a vice president at a couple of different startups working on like digital design and also dancing professionally. And then I decided that I was sick of doing these two different careers and wanted to try to bring them together, and got really entrenched in the art and technology scene in New York. And that scene is crazy and so cool, and very much like a STEAM firework combustion. But it's essentially people from all different kinds of backgrounds that are making really cool work and using, the latest sensors and sensing technologies and writing software, and like not being so prescribed about it or so academic. And it was through that community that I met a woman named Amy, who was the director of a robotics lab in Illinois at the time, who invited me to be the artist in residence there. So I wound up with like a very circuitous path into STEAM, but I loved programming and choreographing robots so much that I was like, I want to do this as a job. I want to do this as my full-time job. And so where are the robots? And the robots were in only a few places, right? They're either at universities or they're at companies. But while I was there, I completely rekindled my passion for doing scientific research. I'd actually done 4 years of research in my undergrad with a organizational behavior PhD student. So I knew a lot about the scientific process and scientific method and how to run experiments and, formulate them. And so I applied to Stanford, and I have to say, this was my first choice, and I was so intimidated to apply that 3 days before the deadline, I just spammed like every professor at Stanford and said, like, what do you think? Do I have a shot? And one of them wrote me back. And that was enough for me to apply. And now I'm here. So very much like Claire, I think the question around how do you finance your education is a really important one. We have to be super transparent about how this works, because that's a big accessibility piece. And PhDs are funded. So most science PhDs, the vast majority of them, so you actually don't pay tuition and you receive a stipend and it winds up becoming a full-time job. So it's my very long-winded response to my STEM career. But I think it really came from like pursuing your passions and then having a few different core people along the way being like, yeah, go for it. You know, what's the worst that could happen? So yes, circuitous, but paid off in the end.
All right, so my next question was, how have you overcome a challenge in your career?
I'm happy to start. I think this isn't a, I guess, specific event type challenge, but at the beginning I mentioned that I definitely have imposter syndrome, and it's something that I've dealt with at every stage of my career. I was at Brown and Harvard for undergrad and my PhD, which are these like big institutions. And I think going there, like, while they're wonderful places, they can really bring out like feelings of imposter syndrome. For example, I had been used to doing well. I did well when I was a student growing up, and then I got to this private college and I did not do well on my first midterm, and it made me question, like, do I belong here? Am I cut out for this? And like, should I switch majors? And I think like it wasn't until I found role models at my university that I like felt more like I belonged in STEM, belonged in college, and they really helped me along my path. And I think that's a common theme that has come up for all of us, but just the importance of having these like real people in your life who can just kind of help you when you're questioning yourself. Like, they kind of see all of your strengths and can remind you of those things. And that was helpful for me as a college student and as a graduate student. But then even as a postdoc, which is what you do if you stay in academia after you get your PhD, you continue in research, doing research with a new principal investigator, developing new skills, doing new research projects. And then you start your journey to become a professor. At each of those stages, it's been so helpful for me just to surround myself with peer mentors, mentors who are further along in their careers, just people who can give me advice about their paths, but also who I can kind of bounce my own ideas off of and kind of think about, like, is it normal that I'm feeling this way? Like, what can I do to kind of just deal with whatever feelings that I'm having about various career stages? So I think that's been continuously the most helpful part for me of navigating STEM.
So, Claire, you stole my answer. Yeah, I think actually the biggest challenges that I personally have had to face have been internal challenges. And what I mean by that is having that faith in myself, that confidence in myself, the ability to overcome fear and to quell those little imposter syndrome voices when they come up. Like Claire, I always did well in school, and then I got to organic chemistry. And organic chemistry was a no joke class for me. It just did not connect the dots. Not until towards the end of the semester was I able to kind of like put it all together. It's kind of a make or break class for a lot of people. Many people in that class were taking it for the second or third time because they couldn't pass it. And ultimately, spoiler alert, I am a scientist. I did go on to pass organic chemistry. Everything's okay. But I had to really learn to take every day at a time and to, tell myself that it was going to be okay, and that I was worthy of being a scientist, and that I was going to be able to be a scientist, like by working through that fear, right? And I don't have to go into all the various different tools, like meditation is one of them, mindfulness, yoga, various different aspects, things that I did for myself to help me through that. But honestly, the thing that was preventing me from it more than anything was myself. And once I was able to move past that fear, then here I am, right? Katie?
I think those are both really powerful responses. I think taking stock of where you are, right? The barometer keeps changing as you get older and as you move forward. The barometer, like the field goals seem to be getting into grad school, and then it seemed to be passing my quals, and then it seemed to be finishing my master's. And it's sort of, the goalpost is going to keep moving. So being present, and I actually reflect a lot on the things that I've done in the past that were really hard, that seemed insurmountable, and then I was able to do them. And so I think when it comes to confronting challenges or dealing with circumstances where you feel like it's so challenging, you might not be able to move forward, giving yourself a pat on the back, but explicitly through this past facing point of view, I think can be very powerful. Remember when I thought it would be impossible that I would pass my quals, and then I passed my quals? Okay, great. Like, that's a data point. Remember when I thought I could never pass mechatronics because I've literally never taken an electrical engineering course? Remember when I got an A in that class? And then you sort of like start to build up your scientific data, and you realize that the way you're feeling in the moment might not always be indicative of how you've done in the past. And that can be really empowering.
Can I add in one more thing before we move on? Katie, you just made me think, one of the things that I wish, and this kind of ties back to an earlier question of what I would want to have told my 10-year-old self, but I think asking for help is something that is always, it's always okay and should be encouraged at all levels. So whatever challenge you're facing, whether it's internal, external, I think like as a professor now, like I appreciate when students come to me for help, just because they have either internal or external circumstances that may be impacting them in a course. And I think that's something that like we've been talking a lot about internal challenges, but what we as scientists and people in positions of power can do is create circumstances that make it okay for anyone who's experiencing challenges to get access to help and get support. And I think that that's like finding the people that you can ask for help along the way when you're experiencing challenges is something that was definitely helpful for me at every stage of my career. And that's something that I wish I had started to do earlier.
Our next question for all of you is, what does being a woman in STEAM mean to you?
Everything. It really is my life's greatest passions kind of combined. So I'm super passionate about science. I'm super passionate about nature and conserving nature. And I'm super passionate about uplifting and supporting other people, building community, especially people who may not have had community in their lives. So I think being a woman in STEAM, this is something I get to merge those three passions every day, right? And live my truth in that way.
I think for me, I love being part of so many different communities of women in STEAM. So being part of the If Then network has been so helpful for me just in terms of mentorship and opportunities individually. And I think for me, being a woman in STEAM means that I want to work to create similar opportunities for other women, whether at my career level or coming up. And so I think there's just knowing that I've benefited from everyone who's come before me and knowing that I want to contribute to kind of keeping all of those things in motion is what being a woman in STEAM means to me.
So when we had our kickoff for the If Then ambassadorship, we all received this wonderful book from Melinda Gates called The Moment of Lift. And she writes about her personal experience of hearing stories about women from all different countries all around the world and realizing that some of them didn't have access to basic basic needs, water, the ability to have children safely to use the bathroom in a location that they weren't going to contract a disease or something like that, just basic cleanliness. And it was so transformative for her, Melinda, because there's a lot of data that shows that if you uplift women, that is one of the biggest drivers of economic progress, especially for countries in the developing world. And so for me, what it means to be a woman in STEM is we have so many huge, big issues that we're facing as a human species, right? And some of them have a very clear ticking time bomb associated with it. Sam's nodding because, you know, when we think about conservation, we think about, you know, nature and animals and all these species. Like, these are big, huge topics, and we need to unlock the full capability of human potential. And what does that mean? It means unlocking a lot of women who might not have the same opportunities that we do in different parts of the world. So for me, when it comes to being a woman in STEM, there's a lot of like personal pride that I feel about being female, about representing, you know, generations before me, generations after me. But it's also about how can we think about the fact that there's half the global population, and in some countries, really unempowered. And how can we unlock that full capability of human potential, regardless of sex or gender, in order to realize some of these big and tackle some of these big challenges that we're facing as a species. So that's what it means to me to be a woman in STEM. I think there's such an interesting discussion that maybe will be had for another time, which is like, just to be in STEM, period, regardless. Like, I identify a lot with that, of being problem solving, of looking at an issue from many different points of view and thinking about how we can work with interdisciplinary teams to solve a problem. But when I really think about like being a woman in STEM, to me, it comes down to being able to mobilize and get the full breadth of human potential and possibility behind some of these big problems that we're facing.
Yeah, one thing is for certain, we are not going to solve climate change unless we have all voices at the table, right? And that includes all women.
The next question is, what tips can you provide to the after-school program staff on how to encourage young girls to be more excited and interested about STEAM careers?
Yeah. Oh, sorry.
You go. No, you go. Okay. I think really demystifying STEM. And what I mean by that is instead of STEM being kind of this nebulous concept, this like, oh, science, it's math, it's hard, it's, I don't know if I do it, I don't know if I belong there, right? Showing students that they're already doing it every day in their life. So you can ask them questions like, hey, I see you're reading a mystery book, right? You like mysteries. Guess what? Solving mysteries, that's STEM. Do you like puzzles? That's STEM. Do you like asking questions? Are you curious? Do you like knowing how things work? That's all STEM, right? And when you demystify STEM, I think that really drives the point home that they are actually already doing STEM and they are already scientists, right? I think giving them those tools, and then you can do that in a variety of different ways, like through those questions, but also just by doing really fun STEM activities, right? That shows them that, hey, STEM is in your everyday life. You're doing it every day. It's not some unattainable thing that only certain people do, right? And also, it's really fun to do it.
I completely agree with Sam. One of the things that I thought of was, yeah, just anytime you can showcase students that they are scientists just by asking questions and approaching things using the scientific method and coming up with hypotheses. I also encourage after-school educators to definitely showcase the diversity of career paths and real women who do STEM. I think we've been talking a lot about the importance of role models, but definitely like these are not just the people who are like, definitely highlight people who are really famous women in STEM, but also I think if you can partner with university programs that do science outreach, having college students come in who are majoring in science and work with students in after school programs and at the K-12 level can make such a huge difference just in terms of being able to see women who are just one step ahead of these students in their careers. It just like kind of being able to have role models at every stage can be really helpful. I also, when I was thinking about this question, went and found this book that I can't remember where I got. Oh no, that's not helpful at all. Okay, well, it's called Women in Science, 50 Fearless Women Who Changed the World. And I love this book just because I have so many students who come into my classroom, and one of the things that I do in class is I try and highlight the people who do science. And often I'll have students say like, oh, like I actually had never thought, like I didn't have a role model who was a woman in science until we learned about like these people. And so I think like really just highlighting, again, women at all stages of their careers, whether they're college students or women who are in history books, like it can make a huge difference. Sorry, these Zoom backgrounds.
I would also add, one thing that's great about STEAM is it's super hands-on. So you get to get dirty and make stuff and build things. And so I think in terms of encouraging people when it comes to after school, like programs that might get mobilize more women and girls in STEM, like making stuff is really fun. This is such a like overused example, but baking is a lot like chemistry, right? You got to weigh things and put them in the right order and make sure that it all comes together. Fashion is a little bit like mechanical engineering. You've got to assemble things in the right order. Otherwise it's going to be like wonky and strange. So I think really hands-on activities is what I would emphasize. And robots are a great place to start. I know I'm biased, but Adafruit and a couple of great companies, they have all different kinds of circuits where you can see like how sensors get computed and turned into like wheels moving around. And so for me, when it comes to being hands-on, we spend so much time on screens, we spend so much time in books. And I think about the experiences that I really remember, and it was like making a volcano with baking soda that blew up, and like I still remember that X number of years later. So I think that sort of hands-on, like really having a body-based experience where you get to get your hands and nose and face and hair dirty is what I would encourage.
So we are actually at time, so we're gonna have to wrap up. I do just want to say thank you so much to Sam and Katie and Claire. Thank you for joining us and for this inspirational conversation. Because we're at time, I'm not going to share all the insights that I had, but wow, I'm so inspired. And then I just have to say a very special thank you to Bella and Megan and Hajira. So thank you so much for joining us and for moderating this panel.
Thank you.
Thank you so much.
Thank you so much. Great to meet you all. I'm inspired by you. So
Thank you.
see you.